Let f of x equal x cubed plus 9x squared minus 81x plus 12. Use the definition of a derivative or the derivative rules to find f prime of x. Well, since we know the derivative rules just fine with the power rule, let's use that to find our derivative. So f prime of x here would be 3x squared plus 18x minus 81. Use the definition of a derivative or the derivative rules to find f double prime of x. Okay, the second derivative then, just using the power rule again, 3 times 2 is 6, so that's 6x plus 18. On what interval is f increasing? Then on what interval is f decreasing? So to answer that, we probably need to do a little bit of analysis. So the thing about increase and decrease is a function is increasing whenever its first derivative is greater than 0. It's decreasing wherever its first derivative is less than 0. So let's do some analysis with this and see if we can determine that. So an easy way to work this out is to start off with a number line. And on that number line, we put the zeros of the first derivative. That's why I've labeled this line with f prime. The zeros of this first derivative would indicate where we have local minimums and local maximums. So places where we change from increase to decrease, and these are the things that we're looking for. We want to know where we're changing from increase to decrease because that tells us where our intervals of increasing and decreasing are. So I'm going to take the derivative, set it to 0, and solve. So let's see, first off I can divide everything through by 3 and simplify things. So that's x squared plus 6x minus 27, I believe. And then if we factor here, x and x would multiply to x squared. 27 could be 9 and 3. And if it's positive 9 and negative 9, then that would multiply to negative 27, but add to 6. Alright, so that means I have zeros at negative 9 and positive 3. So I'll put those values on this number line. Now, to see where this first derivative is positive or negative, I have to pick some test values. So the test values I choose are just something within each interval. So for instance, negative 10, 0 would be a great one here, possibly 4 there. And I want to find out if the derivative is positive or negative there. And you're certainly welcome to use the calculator to determine that. Or what I find is if you use this factored form, it's fairly straightforward because when you take negative 10 and plug in here, this would be negative 10 plus 9, which would be negative 1. Then negative 10 minus 3 would be negative 13. And I don't need to know what that value actually is. I just need to know that it is positive. All right, now when I take 0 and do the same thing, 0 plus 9 is 9. 0 minus 3 is negative 3. And that is a negative value, so decreasing there. Then 4 plus 9 is 13. 4 minus 3 is 1, so positive there. And it's fine to use this form of the equation so long as this number that you factored out originally wasn't a negative, because that's the case. It's like then you're multiplying by, say, like a negative 3. You need to pay attention to that because that would change where you're positive or negative. Anyhow, we can now determine this. So the first derivative is positive on the interval from negative infinity up to negative 9. And then it's positive again from 3 to positive infinity. So that's where the function is increasing. So then it's decreasing on this interval here from -9 to 3, where we have a negative derivative. All right, then the intervals where we're concave downward or concave upward, the process really is the same. All we're looking for here is now for concave down, where is the second derivative less than 0? And for concave up, where is the second derivative greater than 0? So we just need to take the second derivative, put all of its zeros on a number line. So if I take 0 equals 6x plus 18 and solve that, looks like I would have negative 18 equals 6x, so x is -3. So that's my inflection point, and that would be where the function changes from concave up to concave down, or vice versa. We just have to test to find out. And the test is the same. So -4 is on this interval, 0 is over here on this interval, and if I put -4 into my second derivative, 6 times -4 would be -24, plus 18 would be -6, so we're negative here. Plugging in 0, 6 times 0 is 0, plus 18 is a positive value. So what that means in interpretation is when my second derivative is less than 0, so from -infinity to -3, my function is concave down, and from -3 to +infinity, where the second derivative is positive, that means my function is concave up.